everyone. So we're going to continue on our discussion of factoring by talking about another type of factoring that we could do, which is called factoring by grouping. Now, I did notice that some people seem to have already know this. I mean, it is review from Algebra 1, but I want to go over it again. So first off, in the notes, it reminds you about the degree of polynomials. Remember, this is the highest power in your polynomial. So for example, this is a fourth degree polynomial because the highest exponent is a 4. So far, the only polynomials that we've really been dealing with as far as factoring through the AM method, and I think that was basically it, were polynomial degrees of 2. So it was x squared being the highest term. But here we're going to actually look at polynomials with even higher exponents. And in particular, another thing that we're going to look at is polynomials that have 4 terms. Before, again, we only looked at either 2 terms or we looked at 3 terms. If we saw a 2-term polynomial, we did dots. If it was 3 terms, we used the AM method. So now we're going to look at using grouping for 4 terms. We will see in a bit in the next video how we can do this for other types of polynomials, in particular a 3-term polynomial, but for now we're going to stick with the 4 terms. So there's about 4 steps that you do with this. So you take your polynomial, and what you're going to do is first, if it's not done so yet already, you're going to rewrite in standard form. It doesn't really have to be, but it should be relatively in somewhat of a standard form. Remember that standard form means that it's decreasing an exponent. So you have your highest exponent here, then the next highest, all the way down until you get to the constant. So in this case, it's already written standard form. Then your second step is you're going to group the first 2 together and the last 2. So we're going to group these first 2 and then these 2. Be sure to include the negative in here with this 4, as that will play a factor. So we're going to have it grouped like this. So the t cubed minus 3t squared is grouped, and negative 4t plus 12 is grouped. Then what we're going to do is factor both of these groups using greatest common factor. So again, we're just kind of rehashing everything that we did before. So looking at this first term, there is no common coefficient, but they do share a t variable. And in fact, the smallest exponent on our t is a 2. So that means I can pull out a t squared from this term. From the second term, so I'm going to end up dividing out t squared from both. And then from this term, they don't share a common variable, but they do share a coefficient. In fact, I could divide out a negative 4 from both of these terms. So that's what I'm going to pull out. A t squared from this first term and a negative 4 from this second term. And what I'm going to end up getting is t squared t minus 3 minus 4 t minus 3. Because t cubed divided by t squared is a t. The t squares on this one drops out, I'm left with a 3. This leaves me, drops out the negative 4, and then 12 divided by negative 4 is negative 3. Now this is how you know you're doing it right, because this term and this term that's remaining after we pull everything out using greatest common factor leaves us with the same thing. From here, I'm basically going to do greatest common factor again by taking these out and then combining what was pulled out from both of these into their own group. So what I'm going to do is I'm going to pull out t squared minus 4, put that in a group, and then the other side will be t minus 3. So this will be my factor. Now, technically, I actually can factor this one more time. So I factored it once using the grouping method, which again is a combination of grouping and greatest common factor. But I can also do dots. I can do dots because right here is a difference of 2 squares. So this would actually be factored one more step as t minus 2, t plus 2, times 15 minus 3. So don't forget that when we do these factoring, you can factor multiple times. Sometimes you're factoring one time, sometimes it's two. You can factor all the way up to 3 or 4 times. It really depends on what you're given. So after you factor the first time, you want to double check your numbers and see if you can factor one more step. All right, here's some practice questions. Pause the video, work itself, and we'll go over in a second. All right, so my first step is to rewrite these in standard form. If we look at both of these choices, they're already in there, so I'm not going to worry too much. Then my next step is to group them. So I group the x cubed minus 3x squared and the 4x minus 12. There's no common coefficient, but there is a common exponent, a variable. So I can actually pull out an x squared from both terms. So I'm left with x cubed divided by x squared is just an x. 3x squared divided by x squared is negative 3. Here they don't share a common variable. They have a 4 that I could pull out. And then I'm left with 4x divided by 4 is just x. Negative 12 divided by 4 is negative 3. I have an x minus 3 and x minus 3 here. So I'm just going to pull these two coefficients together. And I get x squared plus 4, x minus 3. Now you may notice this looks very similar to what I had before in the practice. So a good question is, could we follow this up with dots? No, because this is not a difference of two squares. Remember, difference of two squares needs a negative. This does not, so this is actually as far as I can factor. All right, going back to here, array in standard form, group the first two together, group the last two, making sure to keep this negative in there. And that's what I'm going to do. Common variable x to the fourth, that's the smallest exponent. So x to the fourth gets pulled out. X to the fifth divided by x to the fourth is just x. 7x to the fourth divided by x to the fourth is just 7. Here, so I can pull out a negative 2 from this. So this just becomes x. Now here, I'm going to end up having negative 14 divided by negative 2, which is a plus 7. Again, my first term and my second term match, so I'm on the right track. I'm going to pull out these two coefficients, x to the fourth minus 2, and x plus 7. Just do a quick check. Can I factor any further? No. I can't dots this because 2 is not a perfect square. And that's pretty much it. There's no other thing that I can do. Alright. Here's the next practice. Pause video, work on the cell phone, go over in a second. Alright. Once again, both of these are in standard form, so I'm not even going to do that. So I'm just going to group these first two and last two. Common variable that can be pulled out is x cubed. Smallest exponent. And then I'm left with this will just be a single x, and this will be left with 1. Here, the common variable is just going to be 6, and I'm going to be left with x minus 1. Now, even though if you're doing this right, you should get these two terms the same, you do want to make sure that they are the same, just in case you might have made a mistake. Sometimes, if you end up not getting similar terms, what you can try doing is grouping two other terms, maybe move things around. But for the most part, as long as you set it up properly and you group the right terms together, you should end up getting this correct answer. For this one, we're going to, again, group first two, last two. Make sure to keep that negative in there. Here, I can't pull out a coefficient, but I can pull out variables. X squared is what I'm going to pull out from both of these. So I'm going to be left with an x squared and then 3x in here and a 5 over here. In this section, so I need to pull something out that is divisible by this. Now, again, one thing that I can use to kind of guide me is look at these numbers. This should end up becoming a 3x. So I can ask myself, what times 3 would give me 21? 7. So maybe I should try dividing out a negative 7. We'll just see if that works. So 21 divided by negative 21x divided by negative 7 gives me 3x. Negative 35 by negative 7 is positive 5. So I do end up getting the same thing. Therefore, I could follow through, take the x squared from here and the minus 7 over from here, and then multiply this whole thing by 3x plus 5. So once you get the one term factored using greatest common factor, you can use that as a guide for the next one if you're not too sure what factors to pull out. All right, here are the next two. Pause the video, work on cell phone, go over in a second. All right, so first off, I think these numbers are wrong. This should be number 5 and 6, I believe. All right, so once again, factor group already in scientific in standard form. Pull out an x squared, and I'm left with x squared x plus 5. All right, since this is a single x, that means I could probably pull out a negative 9 from both of these terms. So negative 9, this would leave me as an x. Negative 45 divided by negative 9 is plus 5. So I end up getting x squared minus 9 times x plus 5. But I am not done because remember, I now want to double check to see if I can factor one step further, and I can. This is a difference of two squares. So square root of x squared is an x. 9 square root is 3. So I'm going to write x minus 3, x plus 3, and I can't forget this x plus 5 that I had before. So this is my complete factor. Remember, just because you factor it once does not mean that you don't factor it again. All right, down to number 6. So we group the first two and the last two. And then, well, I could pull out a 2 and an x cubed. So I'm going to do that. 2x cubed from both terms. And I'm going to be left with 2x cubed. And then in the parentheses will just be an x squared and a minus 2. And then if I look here, there's really nothing I can pull out. So I'm going to be leaving a 1 in front of there. So now I'm going to end up having 2x cubed plus 1 x squared divided minus 2. I can't factor any further, so this is where I'm left with. And that's pretty much it. That's all factoring by grouping is. Again, we're going to see next time one step further of how we can do this with trinomials. All right, so here's the exit question. Try to answer this using what we talked about. If you have any questions, please let me know. Otherwise, I'll see you later. Make sure to come to extra help or ask me a question on our mind. Good luck and have a great day.